Okay, now last time we finished chapter 7, and we finished at page, we finished the stability of couple cation, right? Now, let's move to question number 5, we did it. Question number 6. Okay, now move to part 5, alkene reactions. Halogenation of alkene. And 14. Okay, now let's start. The main thing I want you to know today is the mechanisms. That's everything.
I didn't bring my past paper.
Past paper. You don't have it here?
I'll go get the copy.
No. Share with Danny. Share. Vivian, you can find someone. Eunice, you have already, right? Okay. I know it's looking ready. I should make an announcement that it's already. Okay, the first thing I will show is, I will show the mechanisms. And then we will discuss with it, and then you need to apply by yourself. Now, let's start with an alkene. For example, the most simple one. Okay, how about this one? And then in the reaction, you will see Br2, right? So, and usually the reaction is carried out in ether. So, what ether? What is ether?
Organic solvent.
That's solvents, right? Usually when we talk about ether, this will be done for ether. Now, keep going. So, Br, what's the bond between these two Br atom? Br and Br. Covalent. Polar or non-polar?
Non-polar.
Non-polar. Okay, but that's it on average. But at certain moment, they will have a kind of, how we call it? You can think like tug of war. At one moment, one may have more electron than the other. So we can call this a temporary polarization. So for example, at a certain moment, this one is stronger than this one, right? It's just probability. It's happened by change. So at a certain time, this one stronger, and it has more electron. It's not stronger, but it just have a chance to have a more electron. So this one become a little bit negative, and this one become positive. But remember, this one just happened instantly. This thing it just happened in a certain moment. The next moment, the thing may change in an opposite way, right? And then what next? What we can do here? First of all, look at this one. This one become a partial positive, right? We have a lot of electron. We can give it to that one. But again, this one is. But again, this one is also have lots of electron too. So it can give back. And then this one, the first step is the most complicated one. And then you will have this structure. How you get the structure? Bromonium ion. And remember, so the first step includes donate electron to one of the PR, okay? And break the bond between those two PR to form PR minus. And then this one has a lot of electron too, right? It will donate electron back to the alkene to form the ring structure. Do you know what is the meaning of this one? They are on the same side. Okay, now tell me, in this intermediate structure, which one can act as an electrophile? Andre?
HBr should take one of the bonds to itself.
Which one?
Well, either bond.
This one or this one, right?
Yeah.
What, this one you mean?
I mean, I'd say either because actually I'm not really asking question. I'm not sure which. But
So I mean, which one become partial positive? Which carbon become partial positive? D2, right? Why? You have a positive species up here that will try to suck electron from its neighbor. But which one can stand a positive better? The middle one because secondary. So think like this one can share the positive with this one or this one. But it will share with this one more often because it's more stable. So now what happened next? I am Br, right? I'm a nucleophile, I have negative charge. What I'm going to do? I'm going to bind to the positive place. Between these two places, this one is more positive. What happened with this one? Break. Can you follow so far? And what do we have? This one, even though it's not chiral center, I just write it for you. That's one thing really interesting about this structure. Think like this, the ring in this way, right? And this is Br. And the Br minus, they will attack in from the front or from the back. Why?
Because the secondary is more positive.
I mean, it can, for example, this right here, right? So Br can come here to attack here, or Br can go around to attack at the back. Which ways we prefer?
Back.
Why back?
I don't know.
Why back? Why more stable? Steric hindrance. Because in the front, right, you have a ring with a Br. So it's really huge in the front. So the Br here, if it wants to approach this carbon, it needs to go to the face with less steric hindrance. So this will go behind of the Br group. So that's why. And this is super, super important. You understand why not it attack to the back? Because look at this one. What do we have at the back? We have only a hydrogen. In the front, we have a ring structure with Br, one of the biggest atom, right? And at the back, we have only hydrogen. So it would prefer to a less steric hindrance surface attack from this one. So this one we call halogenation of alkene.
This is called halogenation.
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 Now let's review. This one is super, 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 super important because all of the later reactions is have the same thing, right? Again, I am nucleophile. I want to give electron to positive space. Where do I have? I have a PR. It's not super positive, but it happened. And I give it to BR. BR give it back to me, and the bond between two BR is break to release bromine ions. And I form this structure we call bromonium ions. And remember, this ring that will create a difference in the steric hindrance. But anyone ask me? Anyone has any question? How the ring form? The ring form is here.
Yeah, no.
But why you ask why is it in the front? Can it be in the back? Can it? Yes. Another thing I didn't show is there's another molecules will form the ring like this, right? At that time, Br will attack from the front, and your final product will have the mixtures of two enantiomer. How we call them? How you call this mixture? When they have a mixture of two racemic. Racemic is a reaction of, a mixture of equal amount of two stereoisomer or two enantiomer. Racemic mixture. I'm not sure if there's an R here, but racemic mixture. So this one, they give you a racemic mixture, right?
I forgot a question about the BR.
Mm-hmm.
The reason that there are parts positive and parts negative is because their electrons are actually delocalized.
No, actually, think like this. Electron, it just have chance. It's meaning the distribution of electron is beyond chance. In theory, these two should be equal, right? But because you cannot stop electron, at certain moment, this one will become partially polarized. Just because this one accidentally or randomly have more electron. This one just have less electron.
Is this something like Heisenberg uncertainty thing?
I don't want to get into that one because I don't understand that one that
Okay.
detail. But just my main point is the bond here at certain moment can be partially polarized. Okay, now look at the reaction in your booklet. Can you run the reaction by yourself? Try it. Monoion, what do you mean? Which ion?
Like, in this case, they form the.
Bromonium ion, right?
Yeah, but I think right here they don't form the hydrogen ion, they form carbon.
And remember, everyone, why Tara asked me anything, Frank make the same mistake? Why in this case, we don't have bromonium ions? Why? Because the Br here is equal with the Br here equal with. So Br here is only act at nucleophile. Br here may act at electrophile.
Oh no, I mean the hydrogen. Why don't those two carbons share that hydrogen?
Oh, hydrogen can't because it can only form one bond, and it cannot accommodate more than one.
Or is this reaction reversible?
Reversible?
Yes.
That's a good question, and probably yet.
Yes.
Yes. But when you have high concentration of this one, it will favor the other way.
Why?
This product have a lower energy.
Oh, it has more energy.
Okay, now your task is now finish the reaction with the ring. But I want you to show me the stereoisomers. Yeah. Okay, now what happens if I have a ring like this? And okay, show the mechanisms. Who will volunteer to come here? I think you can do it, but wait, next time. Eunice, go here. You want to? Okay, Caroline? Okay. Show me how you can form the stereoisomer. The first step is the most complicated one. So how you can form the bromonium ions. With this one, you still cannot form the ions. You just form one bond, right? So one of the electron not give back to one. Good job. Keep going. I want you to show me the stereoisomers.
Okay.
Maybe, for example, the bromonium ions can form in the front. Okay, you choose to form in the back. Keep going. Good job. And okay, that's another case. Okay, good job, thank you. Okay, now everyone look at this one. The first step when you see alkene and halogen form halogenyl ions. And in here your friend choose to the first one. How about from the bromonium ion and the back, right? And the back. And remember, if you don't understand it, at least memorize how to form the bromonium ions. And then the next one is we have the Br. So which carbon I should attack? Or they are the same? They are the same, right? So I can attack here, I can attack here. So this one is not selective. It's not stereo selective, right? So I will come here and come from the front or from the back. Vivian? Front. So the thing I have is own ways trans, right? We call this one is anti-addition. You know why? Because two atoms add to the molecules on different size. Anti-addition. Good, 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 good. Okay, now the next version will come here to show the mechanism of the following reaction. You have 1 minute. Next one. So for reverse reaction, how many molecules actually you can form? Everyone? I mean, two. Forget it. Okay, let's start with this reaction. This time, Wendy? So first of all, you can think it's slightly polarized, right? So this one can act as electron. So this one will get electron. This one break. And this one also have electron. And this one will give back to the ring. So this one will form your unit. Because this transient state is more stable. Because this positive charge is shared between two molecules. So this will be more stable. Because hydrogen cannot form more than one bond. So that's their only option. With Br, they can form two bonds, right?
How many is first BR? Seven.
Huh?
There is BR.
Pr, yeah,
Seven.
seven valent electron. Okay. This one will be a little bit more complicated. Good, good. You are on the right track. Okay. This is in the front or in the back? Okay. Just show me one. Just show me one. That's very excellent. Okay, everyone. How about this one now? The first step are not perfect yet, right? To form a ring, this Bi here need to give back an back electron to. It's receive one, and it break two. It's receive one, and it give two. One for the other Br, and one for the other carbon. Only that's where you can form the ring structure. And don't forget, Bi here has positive charge, bromonium ions. Okay, good. And you decided to form the ring in the front, right? So this carbon here, they will be at the back. Agree? Okay, good job. And the Br between these two carbon, which carbon is will attack? Left or right? Left because tertiary, more stable. So Br will attack, but because the front is occupied by the ring already, so it will try to go to the back. But you need to show the reaction here, not perfect yet. When it go here, this carbon cannot form more than 4 bonds, right? So you need to break it. And this is what you have. Br on the left in the front. The other Br at the back, and this metal group is in the front.
I still don't get how Br forms 2 bonds there, because Br has 7 valence electrons. If it forms 2 covalent bonds, wouldn't that violate the octet rule?
But again, it has positive charge. It still have only 8 electrons.
Well, if it has positive charge, it has 6 valence electrons.
So they will have, this is what you have. If you talk about Lewis structure, they also have 8, 4 in the bond and 4 in lone pair.
They only have 4 in lone pair.
Yeah, usually they have.
Oh, never mind. Okay.
Okay. Okay. Good. Remember, the most complicated one is from the bromonium ion. And then the next question, where should you attack? Okay, I have another question for you. And next person needs to come here to finish this reaction. And this is super, super important. And here I have BrCl. This molecules also exist. Now let's start.
For the addition on the lecture slides, they actually gave us 4.
Because this.
Also have trends. They seem like the cis is more possible, but
Yeah.
trans is also possible.
Can I look at it? No, I mean, the product we just show is we call major product. We also have, it will attack, for example, now let's look at this one here. Okay? This one will form a more stable product, but there are some Br also can attack here. But about a percentage, this one will be lower. And the thing, when we just show it just one, we also have another one, which is, and it's mean the bromonium ion from at the back. So bromonium can form in the front, it can also form in the back. So that's why this one will give you a racemic mixture. But again, between these two positions, this position will be favored because it will be more stable. But in the organic chemistry reaction, you won't have a reaction with 100% yield. No, you will have side products. Yes, it will form 4 products, but 2 of them will be major. Okay, how about this one? Next one in line. Danny? So the first one, this also look like halogen, right? But tell me which one will be more likely to be positive? One. Right? This one, chlorine have higher electronegativity, so they can make this one become partial positive, partial negative. And then what's in the reaction, Danny? The first one form the bromonium ions. You need to know how to form it. Okay? First of all, keep going. That one is correct. But the first thing is give from double bond. So double bond give one, receive one. Br receive one, give two. Okay, the intermediate will be okay. So then he decided to show the bromonium ion in the front. Good job. And now what else? What is the nucleophile we have here? Cl minus. This will attack to from the back, right? But wait, that carbon cannot accommodate more than 4. So what happened with the ring? Good. Keep going. So now Bi is at the back, right? So Bi will push the metal group to the front. Yeah. So it's like in here we have Br, right? In here we have metal group. So this chlorine go behind the metal group. So it will push the metal group in the front. Here. And chlorine and bromine will be on opposite side. Okay? Feel better? That is perfect. And again, this one is major product, and another major product will be the other one, right? So this one will form race mixture. And this one is chlorine.
About the major products, they are classified as major products because they form in
more stable intermediate.
if they are formed by more stable intermediate, they are major products.
They make more product. It's like a competition. So if you are more stable, you exist for longer time. The higher chance you will react. So that's why this will favor the more product. Usually in exam they will ask you to write the major product.
So in this case, which one is the
Huh?
most stable one? In this case, which one is the most stable?
D2 is the same. The other one, the other two, which is less stable is Br on this side and chlorine on this side.
But they do form like
They form, but with the lower
okay.
percentage, with lower yield. Okay? Good, good? It depends. Read the question. The question may. It depends. They will show all of the product. You will write 2. But very often in your exam you will say if form a race mixture, only show one stereoisomer. So you can choose one of them. But read the question.
So the electrons in the world goes to the double bond or goes to the tertiary carbon?
That's a good question. Actually, the electron from double bond go to Br, and Br go give back to one of them to form the ring. We don't know that's left or right, but it just you can choose to give it here or give it here. But very likely, in theory, it will give to this one, because when this bond is break, right? When this one is break to form a transition state with Br, this one will accommodate your positive charge because it's more stable, and electron from Br will give it to tertiary. So give back to the higher stable carbon, right? But in your textbook, they don't show the mechanism less closely.
Is there a specific term for the non-major products?
What do you mean?
Specific term for non-major products like that?
Side product? It's not
Side product.
So is so what kind of two doesn't like this to use?
So what is the good relationship between these two?
Meal? No.
Anyone?
Stereoisome.
Actually, they are
In
they are mirror image, right?
yeah.
Just now, think. Flip this one. If I flip this one 180 degrees, this is what I have. And what is the connection between this one and this one? Mirror, right? They are metal, glory. And how do I know that's a mirror image? This chiral center has the opposite configuration. This also has opposite, right? We will come back to this one very often.
So it's meso.
Hmm?
Meso.
No, ENT1.
Meso. Okay.
Why is that one less stable than?
Which one? This one?
Yeah.
Because in order to form this product, right, chlorine must attack to
Oh.
this one, and this one is less stable. So because in your lecture notes they show form product. Okay, now move to next question, number 2. We call haloharine from alkene. So now let me tell you something really fun. That you need to read the question very carefully. Now the only thing different with the previous question will be now Br2, but beside Br2 they are in, we call this a bromine water. Now what is story? Start.
But I think you're missing out 2 in this here.
Huh?
You just said BR, but should be BR2, right?
Br2. This one is Br2, everyone. Br2. It's exactly the same. But your solvent now is not ether, it's water. What will happen? Eunice, come here, show me the first step. What's the first step, everyone? When you see alkene and halogen, what is the first step? Promodium ions. Show the formation of promodium ions. Come. Eunice, the next step will be you, Jody. Right? Am I right? Phoebe, today you need to go to buy the ball too. Phoebe and you ready to so. So again, I have BR. I can form. Actually, one is partially positive, one is partially negative.
Yeah.
Okay, now what happens?
So,
Double bond will give electron to double bond from double bond. The electron from here. Okay, give to Br. The bond here between two Br will break, right? Wait, the bond break, not Br. Okay, and then Br will give a bound electron back. Good. To form a okay, keep on. So next product will be. So this one we call promodium ions, and super important.
so
You can form in the front or in the back, it's up to you. And remember, this one I just showed one, right?
Like about this one.
another one.
Okay? But remember, this will form a ring. Here. Yeah, form a ring with Br. Same size. Good. And plus. And the other one we have Br minus. Okay, what next step, everyone?
It doesn't happen.
Actually, this one has become full negative, right? Because it just received a whole pair of electron here. Good? Okay. You can go back to your seat now. Everyone, so the first step exactly the same. But what happened next?
It doesn't happen.
Water comes into place.
So now how many nucleophile do I have?
You have water and
I have Br minus and
water.
water. Which one will react?
Water is closer.
One.
It's closer.
Not closer.
Polar.
Not really.
Because it has more.
Which one is stronger nucleophile first? Which one is stronger? Br minus, right? Because it has full negative charge. This one neutral. But why water will react? Why? Yeah? Oh, sorry.
It's the solvent.
The solvent. So
There's more.
there are lots of them. It's like a competition. Even you are strong, but I have million, billion of me, I will win. It's like this is a really attractive girl and there's 1,000 of them. The stronger guy, the handsome guy, maybe not have a chance to beat this one. So the major product will be, right? Anyone can come and show me the next step, the attack of water. Chuck, do you think you can do it? Now, water acts as a nucleophile. It will attack, give electron to the positive charge. One of them,
So it's either.
either of them. So this one is one.
If you look at the H0 plus and Br minus is
Mm.
minus 1.
Yeah. No, Chuck. So now we just formed the bromonium ion, right? So we will have D2. Look at this one, Chuck. We need to form the product with the alkene. So water will attack to.
This.
Okay. How it will attack? Just give electron. Okay, here my electron, take it. Okay, good. Okay, this my electron, take it. Oh my god, I cannot accommodate in 4. What happened? Break which bond?
This one.
Why that bond? You give to this guy. This guy has 5. So, okay, good. And then your intermediate will be, and a lot of you will skip this step. Give me a more beautiful drawing. You need to love it. You need to show it compassion. You need to show it beautifully. You can love it. Keep going. Good. O. Really? Just OH? Or OH2, right? But what happened with my charge?
Positive.
Why oxygen has positive charge?
Because it has extra hydrogen.
Good. Keep going. So positive charge. But next, what is next step? Okay, a base can go into and neutralize the positive charge. How? Show me how. I'm Br, I'm a base, I will grab the proton.
It's like this.
Good, and my product will be? How is it?
Where the water act as the base?
Good job, that's the same thing. Okay. Okay. Okay, good job. So again, if you choose it to form the front, right? This one will attack at the back. So OH will be at the back. And remember, why in your lecture, professor will come back to the issues very the end, right? And he talk about anti or syn addition. But I want to talk with you at this step because it will make it easier. But remember, beside this reaction, beside this product, you also have another one, which is OH. So if you have race mixture, you can draw structure like this. This represents both. Or you can write something like this. This means I don't know it's front or back because it's race mixture. See? But why I talk about this one is really important. And remember, read the question. For example, the question say, just draw your product. You can draw this way. If it form a race mixture, show one isomers. Show one of them. Show all of the possible products. Show all of them. Read the questions. Okay. Next question. Question 8. How can I form styrene? How can I form 2-bromo, 1-phenene ethanol? Please propose your mechanism and explain it. The structure looks pretty weird. And remember, why this structure? Okay, now I will explain what the meaning of this one. Tell me what happens with this PR, positive or negative? Huh? No. Look at this one, carbonyl group, electron withdrawing group. So this one will become partial positive. So if you have a partial positive bromo atom, what will happen? And do you know why they use this one but not use this one? You know why? You need to look at the solvent. It is dissolved in water. Really hydrophobic, right? So in your lab, so this works really well on the paper. But in your lab, this one is hydrophilic. It dissolves in water, right? But this one needs to be dissolved in water. But this one is not dissolved in water. So you will form 2 layers. It won't react with each other. So you need to have something donate the positive PR, but it's in the organic solvent. And look at this one. This one can be dissolved really well in the organic solvent because it's kind of non-polar. It's kind of, right? So this one cannot dissolve anything else besides water, but this one can dissolve in DMSO. So when you want to have the reaction happen, you need to own up the component in the same phase. So that's why the structure becomes more complicated, but mechanism exactly the same. Next one will be Andre. You want to show mechanisms? Everyone, no, just try first, and everyone needs to try. Just wait about 1 or 2 more minutes. Okay. Okay, 2 of you. May I look at first? I want to see bromonium ions. Let me see, Esther. And good. Anything and one more thing. The bond, right? Okay. Esther, Delta, you can try. If you feel slow, don't worry. It will, when you understand it, it will become much faster.
What?
We are working with the old handout.
I didn't bring it to you, but we're using the one.
New hair, right? New hair
Yeah.
color. Where did you make it?
What?
Where did you get it? Chinatown, Koreatown.
No, it's like its own thing. They the I don't know what.
So one of the professional place.
No, not really. Not really. Not really.
Okay. Where is the owner? Okay, okay. First of all, is it from the ring like this?
Oh no, we should not like.
Okay. And when you show the C, you must show the H. When you don't want to show the C, just draw the skeletal structure. May I interrupt it a little bit?
Yeah.
Can I replace D2C by
Yeah, it's,
okay. Anyone want to show me your mechanism to double check? Better. Good, good, good.
And we have to
Lean a little bit. One is from your face. So happy. So happy. I'm so proud of myself. Okay, good. Where's your probodium iron? Here. Okay. What that type here? This one break. Perfect. At the back area, may I look at the mechanisms? Why attack here? Where to attack to form this OH group here? Where should it attack? Where should attack? Attack to? Where should attack? Yeah, you should attack it from the OH, right? First of all, they give you the counter product. Second, between these two, which one is more stable? Right. Secondary, there are another reason. That is, the positive charge here can be stabilized by the more likely it will react. More stable you are, the more. Good. How about Cl2? IO2? Yes. But Br is the most common one. But in the future, if they give you this one, can you form reaction? Huh? How about this one? Can you do it? Yes. Oh, so good. Eunice, you have a question?
Yeah.
In the meantime, can you explain for everyone? Again, try to explain by yourself. So the first one is, you are positive. Oh, I have electron, I give it to you. I give it to you first.
One from this.
This VR
Because
is
it's
partially
So,
positive. So
Because this one is stable.
Yeah, it's
So they won't give.
double bond with
But this one,
electron.
when you see the benzene ring,
VR
they won't react
and then
under normal
VR
condition.
has electrons, so
So
it
the double bond
goes
also
back
will
to
not react. Okay. So
housing.
give it here,
So it
And
form this
again,
structure.
it give it back
And
to
then
one
we
of
have
them.
water, so
To form a ring. But before this, you need to break this one. Okay, to form a ring. Promodium ion.
I don't know how to explain.
Okay.
I don't know how to explain.
Okay, so again, when you see the promodium, when you see the Br plus, think about to form a bromodium ions. And you can see here your friend really cleverly show how to form the structure. Exactly the same. The only thing is, except this one is BR, this becomes this complex structure. And when you have this one, between these two positions, what attack here?
Oh, I made a mistake.
And don't forget what mistake did.
I think it should be the negative charge shouldn't be Br minus.
When?
Oh yeah, it's the same.
Oh.
It's the same.
Okay, so between the position, this one is more stable because
Tertiary.
secondary, right? And it's E in the which spot? We call that E.
Benzene. Cause phenol.
This carbon here. This carbon here is very stable because if the positive charge here, right? They can be stabilized by resonance structure. So between when you see this carbon attack there, and really good, you have OH and OH plus, and again you can use Br as the base. Whatever you can use,
The ring.
you can use, yes. That one is stronger. Actually, that one is stronger. This one can act as a base, right? Okay. Better? Feel better? Yeah, but actually, you are right. We don't have Br minus
Yeah.
in here, right? We have this guy here. Sorry, that's why I feel weird too. Whoops. This one act as a base. But I saw someone use water. But why it's not water? No, yeah, it's first, it's weaker. Second, it's not that abundant. Remember, the purpose of this one is to add everything in an organic solvent, right? Okay, keep going. The next thing I want to explain is Eunice raised really one good question. She asked, why the thing outside this double bond reacts, but not this double bond? Yeah, again, this system we call aromatic system, and they're really stable because they can form resonance structure. So the thing outside of the ring, that will be more reactive. Okay, next reaction. Question number 9. Is that to become boring? So another ways, do you know what's another way to form? Another way to form Br plus is to mix them with beta side. Another way you can form Br plus is to mix with this one. Do you know why?
It reacts easier.
How this one can convert this one into and remember this structure. We call this is barosign. The barosign here is high oxygen. Do you know what is reduct? Actually, this one using oxygen is -2, right? This one, the redox state of this one is -1. They are really strong oxidizing reagent. They will grab electron from environment. And this one, I don't want to show the mechanism now, but okay. This we call radical reaction. So this one will take one, this one will take one to form a radical like this. Right? So this one has 7 electrons. And with the Br, this is a really strong radical really strong oxidizing reagent. Oxygen will give 1 electron. It will take, actually, this one they will take 1 electron from Br to form Br radical, right? It just lost 1 electron. and OH become OH minus. And then this one will react with the other one to form, to create the Br plus. But again, my main point is wait for this one. Why I don't want to mention about it? Because it relates to radical reaction. We will discuss later. But the main message is when you see the bitter side and bromine, the mechanism is to form the same thing. Okay, start. Show me the mechanisms. And actually, this one is catalyzed by an enzyme. So in your lab, it's not likely to happen, but because it has an enzyme, bromoperoxidase. So, but anyway, show me the mechanisms. Assume that you have Br plus. Okay? After you mix H2O2 with Br minus, you will have Br plus. And what's the reaction? Next one is Joey. Joey, show the mechanisms. We have trouble. And this one really alike with Aston question. And then we will move to the next one, the crazy one. Better? Everyone should now be able to draw the bromonium ions. Better. Okay, good. Skip this one. Skip this one. The mechanism here is missing. And honestly, I'm not that sure. Just start with the Br plus. So the first reaction we call is halogenation. The next one is halohydration. So when you see water, very likely this will react because they have a lot. Sorry. Okay, you forgot the possible charge again? Ammonium ions. And then what we are going to neutralize? Water, right? Where water will attack? This one or this one? See? The product has OH here. So that's the equation of water will attack the mass space. So the water attack here. What was happened next? The bond won't break because this one cannot have more than 4 bonds, right? 1, 2, 3, 4. So when this one comes, they will break the weakest bond. Because if you break this, because Br plus is really strong, they will try to get electron to it. So the product will be, keep going. Start with Br plus. Actually, you can take this one like Br plus. So in the presence of H2O2, be careful everyone.
I'm sorry.
Okay, no problem. Okay, the structure, keep going. Keep going. one of the most mechanism question in your exams is the alkene with the halogen and show the mechanism to show how to form the halogen new ions, and a lot of you won't be able to. So that's why focus on this. You forgot something on the bromonium ion. They must have positive charge on Br. Right? And then I also have water. Yeah, so after H2O2 react with Br minus, right? They will form water.
Water?
It's me. Oh, actually no. OH minus, OH minus, OH minus. OH minus is actually a stronger nucleophile, right? It will attack to. Okay, and okay, break that one. Okay, good. And done. So I believe 80% of class now be able to do the bromonium ions. Okay, good job. And remember, this one is a racemic reaction, so you will have both sides. Okay, good?
Why is the orange minus?
Because this one, right? The radical of OH will grab a proton, will grab an electron from Br minus to form OH minus. And from 1 H2O2, you will form 2 OH minus and the Br plus. They won't, this one will be really unstable. They won't exist at Br plus. This is just the way we simplify it. And actually the better way to show it is not a Br plus. I just want to simplify it. The better way to show it is this one. Because we have OH here, right? Radical. And Br minus, right? Oh my god. So this one contribute 1, this one contribute 1 to form Pr. And actually, the other OH radical need to get 1 electron from Br2. So you can see this form is also Br plus. So Br plus can be written in many forms. So now moves next one, promote mechanism for next reaction. Form a group of 2, discuss this question. This one of a challenging question, but look at the product, propose the mechanisms.
This is in chapter 8.
Chapter 8. Don't worry, now if you really understand the reaction, you will be able to do next question. We are looking at the old.
Yeah.
We have it, right? Okay. Tim, use mine. What is the first intermediate? Keep going from the bromonium ion first. How you can form the bromonium ions? We give one to Br plus, give one to the double bond. Form the bromoanion first. So, then what happens next?
We have a question.
Mm.
Which one is which hospital? Which one is active?
You ask. Because of you lost something. Right? Okay. But then you look at this one, you will see which one is attractive. Hmm? Yeah.
Yeah.
Because when you perform mechanics, you need to look at the product. That it's harder to predict the product. But if they give the product, there's only one way to form, right? Attack. Right.
Where is hydrogen?
Hydrogen.
Will be okay. Attack it and form intermediate form. Attack it and find a way to get rid of this hydrogen. And then look at this one. What will happen next? How? Look around. Do I have any nucleophile? Look again. Closer. What is this one? What is OH? And where is it? Okay, very good. Now you need to have a nucleophile, right? But how? Okay, good. Show mechanisms. With the arrow from OH. Yeah, it's closer to this one. Attack first. Good. Good job. You got it. A lot of you, I'm so happy because a lot of you from the bromonium ions, but then look at the product. How we can get a product? How? And navigate your reaction. Oops. Oh, done. Perfect. Yeah? You need to break this one though. Hmm. Yes. Okay, but so first of all, I don't know why you have these bond here. Eraser. Now, right? Nucleophile will attack. That's the next step. So OH has so OH is a nucleophile. They will attack to the carbocation and break the bond,
Break the bond with
and then you will have how is it? It's so simple, right? Instead of water, that is just an OH group. And then what happened next? I don't want this positive charge here. I need to neutralize it. Neutralize it for me. You can use any base, right? Base, anything. Come here, neutralize it. Ta-da! Done. Explain it. What you just. Okay, now let's work together. I know at least about 4 or 5 you have the right answer. Ready? how are you doing? Good. It's so close. But why from here to from this one? What wrong? You just give it, right? You just give it a bond.
Also is true.
Yeah.
Yeah. Okay. I mean, it looks crazy, right? The molecules look so complicated. Now let's start. I'm going to solve this problem as a tool for everyone. And it looks crazily difficult. Okay, the next thing, the first thing I want is, I see Br plus, right? And I agree, there are few different possible double bond here. For example, in this one, I have one double bond, right? In here, I also have another double bond. But how do I know which double bond react? How do I know? Look at your product, right? This double bond is still here. This double bond is still here. This triple bond is still here. So the one react must be this one. So that's why when the proposed mechanism question is the easiest question. Okay, now I have Br plus. Because they give you the answer already. You just come somehow to make sense of it. I give you, you give me, and then I will have something like this. Oh no, I hate this one. So this one, it will form a bromonium ions. And do you know why I'm drawing it in the front? Do you know why? Why I'm drawing it in the front? Because, look at this one. Oxygen is at the back. So in order to form this one, the bromonium must be in the front. Okay? This one. Because this one is in the front, right? So this oxygen must be in the back relatively. So now, I saw at least half of the class got this structure and then you stop and give up. But again, look at your product, right? You need to close the ring first. And second, in order to attack here to form a bond, you need to have a nucleophile. Usually you would think, oh, where's my water? Oh, where's my Br minus? What is the common characteristic of all of these species? They have long hair. But here, you forgot something. Oh, come on. Right next to it, you have an OH group. And as I said last week, there are two cases to make sure that reaction will happen. First, there are a lot of you, or you are just next to it. Just think about relationship, right? The best way to form a relationship, not really for human, but this one is when you two are really close. That bond is easiest to form. And then, I am nucleophile, oh you're positive, I love you. I come here, you cannot have more than 5, more than 4, you need to break. Ta-da! Almost not done yet. And this one will be the intermediate after you to attack, right? And then how you can get rid of this hydrogen here? I need a base, any base, maybe water, maybe solvent. In here they don't give me, so I just base. Or you can write here, base, B minus, neutralize it, done. See? It looks crazy, right? Is it? But is it different with this structure here? Is it different? The mechanisms. This one and this reaction, are they different? No. the first step form the bromonium ion. The second step, nucleophile attack. Done. See? Better? This question will be in the exam today.
Really?
Not this question, something more. Oh, for anyone late, we have an exam today after 4 p.m. We will have exam. But it's up to you. You can stay or you can go home. It depends on, it's up to you.
Can I just say
Huh?
why everyone takes the exam?
Okay, now move. Okay, do you want a break? 5 minute break? Oh, sure, 5 minute break. It may be in front of you. Look at it. The product is in the front. Right? Because the product is in the front. But I mean, yeah, but when this one is the front, you have an orange and this one also actually a back related to this one. So in order to it needs to attack from the back. In order to attack from the back, the bromonium ion must form. So you need in order for the proposed mechanism question, look at your product. It's hard actually. But because in here, when you see orange here, they have and the back related to this one.
So you have to
So it's just the way you got it. Push it. But in that's why you will push the whole protein back.
So it shows by the product.
This is so it shows so in order to attack from the back, the bromonium ion is formed. So that's it for the miscarriage question. You need to look at what do you want and then how you follow it. How is it, Andrew? Is it okay? But it makes sense, right? It's so complicated, but the step is exactly the same. From bromonium and then OH attack, nucleophile attack.
But it does not have the positive charge. Right? This carbon does not have the positive.
Actually, this one is this group here. It don't have the full positive. It has partial
positive. Because there's a dark.
Okay, now for anyone who wants to have fun by yourself, can you tell me and predict what is the product? You don't need to show me the mechanisms. What is the product of this reaction?
How question?
Show me the product. It's thing like this. The bromonium ion is huge, like this. So just think. So in order to approach this one, okay, can you form the hand like this for me?
Yeah.
Okay, sure. So this is your bromonium ions.
Right.
These are two possible places you can attack.
Yeah.
So if you are, I am an ion nucleophile. I'm big. And in order to attack here, I can come here, but see what happened. The electron cloud becomes so close. We call this one is steric hindrance.
Yeah,
But-
can't spell that.
Steric
Yeah,
hindrance. Okay. So HI. So with this one, if I attack from the front, it will be really close.
Yeah.
And they repulse each other. So if I am attacked from the back, see?
So
Easier.
from the bottom.
The bottom, from the bottom.
So the bottom is back.
Yeah,
There.
because there's no ring. From like this for me?
Yeah.
Okay, come here, preponderance.
Oh.
Come here, less. So it's easier. Okay, come here, I need to use you. Come here, unit. Okay, we need to do a small exercise to make sure everyone understands it. So come here. So now units with is an alkene and from a bromonium ion. I just want to explain for anyone still confused. Okay, from the bromonium ions. Okay. Again, this is straight like this. Okay, right? I am an ion. I can attack here. Just think. I am ion and if I'm come from the top, right? Look at this one. This is an electron cloud. This also have electron cloud. So these two are really close with each other. When two electron clouds is close to each other, we call this one is steric hindrance. But if I come to from the back, see? Much less steric hindrance. So that's the reason why BR is empty. Okay? You will never forget it, right?
Yeah.
And actually, think like this. This one is still small because bromo BR is a big atom. So that's why the structure on the top actually really big. BR is in which row? The fourth, right? BR is in the front. F, Clary, BR. Yeah, BR in the fourth. So they are really big already. And electron clouds like this, so try to avoid them. Okay, good. Everyone, still? Are we missing someone? Who?
Okay.
Then. I certainly don't know who's sitting there. Over there, Chuck. Anyone else? Go over
Tim.
there. Huh?
Tim.
Tim. Okay. Danny's coming back with food. Okay. Let's go. Yeah? Oh, I'm sorry. Chuck, show me the product of this one. Oh, I know. Everyone? Show me the product of this one. Wrong. YOH. Okay, show me the mechanism for this one, Chuck. This is CH3OH.
Yeah.
Do it. Chuck, show it. I'm not sure if you're right. Oh, yeah, right. Let's see. What's the nucleophile here?
What's the F?
Oh, M is something not relevant here.
Oh,
So again, this is a question you never see it before. But Chuck gave the right answer. It's not, okay, it's close, but good. But anyone see that something wrong with the bromonium ion?
Oh, right.
Fail. Keep going, -1, keep going. Keep going, I mean, this one has 10 in total. Oh, so big. Minus another one because it looks ugly. It looks so bad. Okay, so sure. But it's just give me a normal one. You know it's big, but you don't need to write it big. Okay, much better. Actually, the dash look really ugly too. But anyway, keep going. The wedge look not beautiful. And another thing, when this one in the front, actually this one, not from the back. Keep going. Actually, another one is missing. Look at it again. Look at your promonium ion. The idea is totally correct. I want to show you 3,
Positive charge.
2,
Positive charge.
the positive charge here on the promonium ion. Okay, you have 6 left. Keep going. It's fun. It's fun. Okay, not bad.
Wait, is it wrong again?
Keep going. Keep going. Yeah, it's good. Don't worry. Keep going. Keep going. So, okay, keep going.
Oops.
Where the attack? Okay, sure. So everyone, instead of water, this one is methanol, right? Methanol is the nucleophile here because it's a solvent. Sorry. It's from the back, right? No, wait. This one in the front. So this one will attack from the back. And that's the back.
So,
Okay.
so it looks like this.
Mm-hmm.
And this also looks like this.
One at the back, the other one must be
Front.
in front. I don't want to subtract anymore. I don't want to hurt your feelings. Okay? Done? So the first step still form the bromonium ion. And remember, bromonium ion has positive charge. Chuck? Positive charge. How to form it? I mean, your idea is totally correct. But don't get lose mark because of the small thing. Right? Because for example, fill in the box, the intermediate, and you don't get positive charge, you lose 2 marks. And then, so in here, instead of water, attack, in here, actually not 100% correct. In here, this guy also have a bad electron, right? So this one will attack here to form C3N plus. And after you neutralize it, you will have the structure the chakra before. So again, you will have countless number of possibilities. Just think, bromonium ion, nucleophile, done. Okay?
Yeah, but why not OH? Where is it possible to?
Where's water?
No, but where's in the C3OH?
Where's OH?
The C3OH.
This one is
Yeah.
C3OH.
Yeah.
After C3OH attack, right? This what you have.
The bond between all of them.
And then how can you kick out C3?
Well,
How? Tell me how you can kick out C3.
uh,
Or maybe my question is, so between H and C3, which one is easier to kick out? H. Done. Right? And neutralize it, and you form an ethyl group. Done.
But it's also possible, right?
No.
Not possible?
It's almost impossible to kick this one out.
Okay.
So,
Because you cannot donate electron C3. It's full. Right? And C3 is, you cannot just kick it out like that. You need to have really special condition. Chuck?
Will I get more than 3 points for this problem?
You got 4. Don't worry, but you have a good idea. Okay, now move to the next part of the handout. How to synthesize alcohol from alkene. Now I will ask you. Review for the last week question. Last week problems. Show me your product. You have 1 minute. Go. We are at the, don't worry, this it just I just write randomly. So what's the product? Anyone? Andre?
English is the word.
In the future, you need to be doing really fast, mechanism in your head, and product right away. Okay. Heartbreaking. You know why? Andre?